Hello everyone, it's me Sanjay Vasu back again for another video. This time I'll be doing it on Cambridge IGCSE Additional Mathematics Paper 1, which is non-calculator paper, Specimen Paper B for examination from 2025. Before we go to question 1, we have a list of formulas which you can use for any of the given formulas, and you don't need to remember these because they'll be given in every single paper 1 of AdMaths exam. Question 1. The diagram shows the graph of y equals a sine bx plus c, where a and b and c are integers. Find the value of a, b, and c. Well, the first thing we can find is the mean position of the sine graph, which is over here. This is the line which is in the middle of the minimum and maximum of the sine graph. So this is minimum at minus 6, max at minus 2. So this line y equals minus 4 is going to be in the middle. So the first thing we can find using this will be the value of c. We know that the minimum is minus 6 and the maximum is minus 2 of this sine graph, and c is simply going to be equal to the average of the minimum and the maximum, which is minus 6 plus minus 2 divided by 2. That's just negative 4. And you see why we got minus 4 here, because the line y equals minus 4 is the mean position. That's the value of c. Now what about a and b? Well, the value of a is just the coefficient by which we stretch the sine graph up or down. That's the value of a. Like, we stretch it, meaning that the distance between the mean position and the maximum, or the mean position and the minimum, will be, in this case, the modulus of minus 6 minus minus 4. That's the same thing as the modulus of minus 2 minus minus 4, which is just 2. And that's just going to be equal to a, because a usual sine graph has an amplitude of 1, but in this case it is 2. So a is just going to be what we multiply it by to get this value, which is 2 as the amplitude. And what about b? b is the value which determines the period of the sine curve. We can see that this graph repeats itself 1, 2, 3 times in an interval from minus pi to pi. And minus pi to pi is usually the period of one sine curve, but in this case it is for 3 separate curves which look like sine curves. So the period is just the value it takes for one of these 3, and that period will be over here, it ends, which is just minus pi over 3. You can know this because it takes 2 pi to go 3 sine curves. So a single sine curve will just be divided by 3, 2 pi over 3. And since the starting point is minus pi, the ending point of the first one must be at minus pi plus 2 pi over 3, which is negative pi over 3. So we can just mark that over here, minus pi by 3. And this over here is 2 pi over 3. b is going to be equal to 2 pi divided by this period 2 pi over 3, which is equal to 3. So now we know the values of a, b, and c, and that'll be our answer. Question 2. The solutions of the equation 5x plus 2 modulus is equal to the modulus of 3x minus 4, or x equals a and x equals b, where a greater than b. Find the value of modulus of 2a minus 3 minus the modulus of b minus 1. Okay, first thing we can do is to try cancelling off the moduluses. So 5x plus 2 is going to be equal to 3x minus 4, or negative of 3x minus 4, yeah? So there'll be two equations now. 5x plus 2 equals 3x minus 4. Let's do that first. That means 2x is equal to minus 6 and x equals minus 3. Now on the other one, we have 5x plus 2 is equal to 4 minus 3x. That means 8x equals 2 and x equals 1 by 4. Now we know that a is greater than b, and the solutions are x equals a and x equals b. So because of this, a is equal to 1 by 4 and b is equal to minus 3, since 1 by 4 is greater than minus 3. So 2a minus 3 modulus minus b minus 1 whole modulus, that is going to be, when you substitute everything in, over here we get 5 by 2 when we take the modulus, and minus of 4, which is going to be negative 3 over 2, and that'll be our answer. Let's go to question 3. Find the values of k such that the line y equals 9kx plus 1 does not meet the curve y equals kx squared plus 3x times 2k plus 1 plus 4. Well, first thing we can do is to substitute these two y's inside, because both of them are written as y equals. So we can just substitute this equation 1 into equation 2. Substitute 1 into 2. That will be 9kx plus 1 is equal to kx squared plus 6kx plus 3x plus 4, since I just expanded this brackets here. Now I can bring both of this to the other side, so it'll both become negative, and kx squared plus 6kx plus 3x minus 9kx plus 3 is equal to 0. And we can write this over here as minus 3kx plus 3x, and that means kx squared, that means k is the coefficient, plus 3 minus 3k times x, so 3 minus 3k is the coefficient of x, and then plus 3, so 3 is the constant, that's going to be equal to 0. How do we find where this does not have any solutions? Of course, we take the discriminant, delta, which is b squared minus 4ac, less than 0, since they don't meet. Now the coefficient of x squared is going to be a, which is k, and 3 minus 3k, the coefficient of x, is going to be b, and c is going to be the constant, which is 3. So delta, b squared minus 4ac, we can write that as 3 minus 3k the whole squared minus 4 times k times 3 is less than 0. So that means 9 plus 9k squared minus 18k minus 12k is less than 0. And 9k squared minus 30k plus 9 is less than 0. We can simplify this to 3k squared minus 10k plus 3 is less than 0. And we can factorize this as 3k minus 1 times k minus 3 is less than 0. And how do we find which one do we put less than 0, which one do we put greater than 0? Well, we know that 3k minus 1 equals 0 proves k equals 1 by 3. And k minus 3 equals 0 proves k equals 3. So these two will be the x-intercept of the graph of this. Let's say this is 3x and x minus 3. So the x-intercept of that graph will be 1 by 3 and 3. So let's just sketch the graph right here. It'll be something like this. So this is 1 by 3. This is 3. And what is the region where this whole graph is less than 0, or it's below the x-axis? So we need this region over here, which is going to be x greater than 1 by 3 and x less than 3, right? So in this case, we just put k is greater than 1 by 3 and k is less than 3. And that's why 1 by 3 is less than k less than 3. This will be our final answer. Question 4. It's given that cot theta equals minus 2 root 6 for pi less than theta less than 2 pi. A. Find the value of sine theta. Well, if cotangent of theta is minus 2 root 6, that means tan theta will be 1 by minus 2 root 6, or negative 1 by 2 root 6. And tan theta is just opposite by adjacent of any triangle, which is right angle. So let's just draw a right angle triangle. Okay, there's not exactly right angle, but there's just a sketch, so it's fine. Let's assume that's the right angle. Let's just assume that this angle is theta over here. Yeah, I know that this angle has to be between pi and 2 pi, but it's fine. We can write theta is this for now. Why we do that? Because tan theta is positive in first quadrant and the third quadrant, which is 0 to pi by 2 and pi to 3 pi by 2. But then, in this case, it's negative. So that's going to be between pi by 2 and pi, and also from 3 pi by 2 to 2 pi. But since it has to be in this interval, it will be an angle in this amount. So in reality, this angle here is going to be theta, but let's just assume it to be this for the sake of drawing a right angle triangle to understand it. So that means let's just remove the negative sign, disregard the negative sign. So this 1 will be the opposite and 2 with 6 is the adjacent. So let's just say this is 1, this is 2 with 6. I know this diagram is not showing that because 1 is clearly less than 2 with 6, but I've drawn as greater. But it doesn't matter, it's just a sketch diagram anyway. This does not really count as an actual right angle triangle we're drawing. It's just a sketch, the scale doesn't matter. So over here, this is 2 with 6, this is 1, and we can find a third side over here, which is the hypotenuse. So let's just say that this hypotenuse is h. h squared is 1 squared plus 2 with 6 squared. That is going to be 1 plus 24, which is 25. Now h is equal to the square root of 25, which is 5 units. Of course, we take the positive square root because it is a length. So h is going to be 5, and the value of sine theta is going to be the opposite by the hypotenuse, which is 1 over 5. And that will be our answer, right? Wrong. We're not done yet, because didn't you remember that the angle has to be between 3 pi by 2 to 2 pi? And sine theta is positive in quadrants 1 and 2, which means it is positive when it is between 0 to pi as an angle. But then between this interval, which is pi to 2 pi, sine theta is negative. So we have to change this over here to negative 1 over 5 because sine theta is negative in this interval. So the answer is negative 1 over 5. By the way, if you're wondering what this symbol means, it is the symbol of because. Let's go to part B. Find the value of cosine theta, giving your answer in third form. Well, cosine theta is just going to be adjacent by hypotenuse. So cos theta is adjacent by hypotenuse, which is 2 with 6 by 5. Using the same right angle triangle which you have, we can just get this, and that's simply our answer. It is in third form. Let's go to question 5. Solve the following simultaneous equations. 3y minus 2x plus 2 is 0 and xy equals half. We can write this equation 2 here, this equation 1 here. So equation 2 can be rearranged as y equals 1 over 2x. Now we can substitute this y equals 1 over 2x into equation 1. Let's say this becomes equation 3. Substitute 3 into 1. That means 3 by 2x minus 2x plus 2 is equal to 0. And we can multiply both sides by 2x to get rid of the denominator, that's why. So that means minus 4x squared plus 4x plus 3 is equal to 0. And 4x squared minus 4x minus 3 is equal to 0, just to remove the negative sign over here. And we can actually factorize this. So we'll put into brackets 2x and 2x, and this will become minus 3 and plus 1. You can write minus 3 here plus 1 here is the same thing. Either way, that's equal to 0, and x equals minus half, or x equals 3 by 2. Now we know the x values, we can substitute to find the y values. So let x equal minus half, the first value. That means we can substitute this into equation 3, which is the rearranged form of equation 2. Y is equal to 1 by 2 times minus half, which is negative 1. And secondly, let x equals 3 by 2. We can substitute this as well into 3. So y equals 1 by 2 times 3 by 2, which is 1/3. And therefore, the answer we can write as x equals minus half and y is equal to minus 1, or x equals 3 by 2 and y equals 1 by 3. And that'll be our final answer. Let's go to question 6. Question 6. Points P, Q, and R have coordinates P minus 4 minus 8, Q 2, 4, and R 10, 0. A. Show that the line PQ is perpendicular to QR. So let's just find the gradient of PQ. That's the first step in finding the answer. So that's going to be equal to y2 minus y1, 4 minus 8, by x2 minus x1, which is 2 minus 4, which is 12 by 6, which is 2. Now what's the gradient of QR? That's going to be equal to 0 minus 4 by 10 minus 2, minus 4 by 8, which is minus half. Now we can take this, and m of PQ is equal to minus 1 by m of QR. We can find that because minus 1 by 2, which is 2, which is 2. So because one of the gradients is minus 1 divided by the other, or if you multiply these two you get minus 1, that's why PQ is perpendicular to QR. The property of perpendicular lines is that the gradient multiply to minus 1, or one gradient is minus 1 divided by the other. That's how I did this. Now for part B, find the equation of the circle which passes through P, Q, and R. Well, there is one property of a circle that can help us. Let's just say this is the circle you want to find, and P, Q, and R are the points over here like this, P, Q, R. Just write it like this. And of course, they make a 90-degree angle over here. Well, that means that PR has to be the diameter of the circle. Well, why is PR the diameter? Because angles in a semicircle are always 90 degrees, and the only way to make this a semicircle is if this is a diameter. So PR is a diameter, and we can find the center of the circle by just finding the midpoint of PR. So let's find the midpoint of PR, and that'll be, let's say, m of PR, capital M used here for midpoint. That'll be minus 4 plus 10 by 2, comma, minus 8 plus 0 by 2, which is 3, comma, minus 4. So that's the midpoint, and that's the center. Sorry, not minus 3. 3, comma, minus 4 is the center. And now we can find the radius by finding the length of, let's say, this point O. Let's actually change this to O as the point name, because that's how they usually call center of circles, as O. So point O is minus 3, 4. Let's just find the distance PO. You can find QO or RO. These distances are still going to be the same as PO because they're all the same radius. So first thing we do is to write that formula. x1 minus x2 the whole squared plus y1 minus y2 the whole squared, square root of this. So that'll be, because we have the coordinates of P, minus 4, minus 8, this will be equal to the square root of 3 minus 4 the whole squared plus minus 4 minus 8 the whole squared. The values I got are from these 2 points over here, and we take 3 from here, minus 4 as the x value here, and then minus 4, minus 8 as the y values. And this 3 minus 4 is 7, because 3 plus 4, and we take squared, so 49. And we add this minus 4 minus negative 8 is minus 4 plus 8, which is 4, and 4 squared is 16. So the square root of 49 plus 16 is PO. And that means we can say that the radius is equal to the square root of 49 plus 16, which is square root of 65. And now we can just write this in the form of the equation of a circle. So r squared is equal to x minus 8 the whole squared plus y minus k the whole squared. And since r is equal to root 65, we can write r squared as root 65 squared, which is just 65. And now we can substitute this here. So 65 is equal to, what is this h and k? h comma k is just the center of the circle, which is 3 comma minus 4. We found it here. So we substitute these values. X minus 3 the whole squared plus y plus 4 the whole squared, because it's y minus k here and it's y minus negative 4, and this negative negative cancels, so we get positive 4 here. So y plus 4 the whole squared plus x minus 3 the whole squared is equal to 65, and this will be our circle equation. That'll be our answer. Let's go to question 7. In this question, the lengths are in centimeters and the angles are in radians. The diagram shows the circle with center C and radius R. The points A and B lie on the circumference such that the angle ACB as given is 2 theta radians, where theta is less than pi by 2. Find in terms of R and theta the perimeter of this shaded region. That's our A part. Okay, first thing we can realize is there's a circle, so we can use both of these as R. This is also a radius, so it's just R. And now since we know that there's 2 theta and angles around a point add up to 360 degrees, or in this case it's radians, so 2 pi radians, this will be 2 pi minus 2 theta. So when we find the arc length AB first, so the major arc AB length is going to be equal to theta r, which is in this case 2 pi minus 2 theta, times the radius, which is r. So that's 2 pi r minus 2 theta r. Now what about the length of AB? We know that using the cosine rule we can find AB. So AB squared is equal to, when you substitute everything into the cosine rule, as this is the big A, this is small b, this is small c, which are the sides. So b squared, r squared, plus c squared, which is also r squared, minus 2bc minus 2r squared cosine of big A, which is 2 theta. So that's going to be 2r squared minus 2r squared cosine 2 theta. And notice that this value we got just now is AB squared. So that means AB is just going to be the square root of this. And the perimeter will be this, which we have as 2 pi r minus 2 theta r, plus AB, which is the square root of this value here. So perimeter is going to be 2 pi r minus 2 theta r plus square root of 2r squared minus 2r squared cosine 2 theta. And that is our answer. Let's go to part B. Find in terms of r and theta the area of the shaded region here. Well, we can split this into two parts. One is the triangle here and one is the sector. Let's find the sector area first. So the area of the sector is going to be equal to half theta r squared, where theta is in radians. Theta is the angle, which in this case is 2 pi minus 2 theta, the angle from the center to the two radii which form the sector. And the radius is just here, r. So we can substitute this, so half times 2 pi minus 3 theta times r squared, which is equal to pi minus theta r squared. And now what's the area of the triangle? We can do half AB sine C to find this, the typical formula. Here in this triangle, we can take this as A and B and angle C as 2 theta. So half times r squared, because r times r is r squared, times sine of 2 theta. Now the total area is just going to be adding these two values up. So it'll be pi r squared minus theta r squared, which is the same thing as this here when we expand the brackets, and plus half r squared sine 2 theta. And this will be our answer in centimeters squared. Let's go to question 8.